So we've already talked about the product rule. Product rule was where we have multiplication between the bases, therefore we add the exponents. We talked about the quotient rule, where we have like bases and we're dividing the like bases, so we subtract the exponents. And in our last exponent rule, we have the powers rule. So powers is when we have parentheses and an entire expression is being lifted or raised up to another power. So we look for the parentheses, we locate the exponents, we keep the base, and we multiply the exponents. Now that kind of makes sense, because if you think about it, when you have something attached to the outside of a parenthesis, that tells us we need to distribute, right? Well, that's what we're going to do, but instead of distributing numbers as a base or coefficients, we are going to distribute exponents and multiply all of the exponents. So in our example, we have a to the m raised to the power of n. So you keep the a, and see those parentheses? That means that this m on the outside needs to come in and multiply by the exponent on the inside. So we keep the a and it's m times n. In our example here, we have ab inside parentheses. This exponent is attached to the parentheses, which means it needs to distribute to the exponents on the inside. Well, you might be thinking, where are the exponents on the inside? Remember, every number has an exponent, and if it's not showing, it's just 1. So we're going to take the m and multiply it by the 1. We're going to take the m and multiply it by the 1, and we would have a to the m, b to the m. Here's some numerical examples. 4 to the third, here's those parentheses, raised to the third. That exponent is attached to those parentheses. That says, I need to distribute. When I distribute, I multiply. And the exponent on the outside must multiply by every exponent on the inside. We keep the base was 4. 3 times 3 is 9. Same thing here. Parentheses with an exponent, that means the exponent has to go meet every exponent on the inside. We keep the base, so we keep the 3. 2 times 2 is 4. We keep the x, 2 times 2 is 4. So 3 to the 4th, x to the 4th. Let's look at some more numerical expressions. Write our answer as a power. Oh, and it does say up here positive exponents. So remember, nothing with a negative or a 0. My base, 1 to the 4th. Here's my parentheses. 2 is attached to the outside. 2 needs to multiply n. Keep the 1. 4, the power of 4 raised to the second power, we multiply, and 4 times 2 is 8. Negative 2 to the third inside my parentheses is being raised up by 5 more. Keep the negative 2 to the third, but negative 2 to the third needs to raise up, and 3 times 5 is 15. So negative 2 to the 15th. 10 to the 10th inside parentheses raised up to the 8. The 8's going to distribute in, so that's multiplication. We keep the base, and 10 times 8 is 80. We have 4 to the second inside parentheses. Attached to the parentheses is the negative 3 exponent. The exponent that's attached to the parentheses has to come in, has to be multiplied or distributed in. Keep the base 4. 2 times negative 3. 2 times negative 3 is negative 6. Ooh, remember we said positive exponents only. We need this to become positive. Remember, we just put it over 1, and that negative exponent divides out to the bottom. We go across the fraction bar. When it goes across the fraction bar, it becomes a positive 4 to the 6th. As we were dividing, that means that there is a 1 left in the numerator. Here, 2 to the 4th times 3 to the 3rd. Inside parentheses means that this 2 up here needs to distribute to every exponent. So we're going to keep the base 2. 4 times 2 is 8 times, keep the base of 3, and the third power, 3 times 2 is 6. keep the base, multiply the exponents. What about with variables? Same thing. W to the fifth is being raised. This entire expression is being raised up to a new power. So we are going to distribute the 6 in. We multiply the exponents. So keep the base, multiply the exponents. 5 times 6 is 30. V to the negative 2 raised to the power of 7. We're raising it up. We're going to distribute that in. Keep the base, V. Negative 2 times 7, negative 14. Oop, negative. Nope, we're going to go ahead and move that across the fraction bar. And when I do move that across, it will become V to the positive 14th. And remember, we were dividing, so there's a 1 still in the numerator. 1 over V to the 14th. Up next, we have a fraction inside of our parentheses, and 3 is out here. Well, what that tells us is that 3 has to distribute in to everyone. Now, what do you mean to everyone? There's an X and there's a Y. That 3 is going everywhere. Go ahead and remember that when there's not an exponent, we're going to go and put that 1 there. And I'm going to distribute that 3 to this one and to this one. So X to the first power times 3, 1 times 3 is 3, over Y to the 1 times 3 is 3. It goes to both the numerator and the denominator. It actually goes to everybody inside the parentheses, regardless if it is in a fraction or if not. Okay, our next one up. C d to the negative 2 raised to the 5th power. That C does not have an exponent, so I'm going to go ahead and give it that 1 so I don't forget it. And then I'm going to distribute. Keep the base. C, 1 times 5 is 5. D, keep the base. Negative 2 times 5, negative 10. That's a negative exponent. I'm going to go ahead and set me up a fraction. I know that that D is going to have to move. The C's fine. So C to the 5th is going to stay, but the D to the 10th is going to have to go across the fraction bar and become positive. I have 2G to the 3rd. Remember, when there's not an exponent, we go ahead and give it 1. And yes, the coefficient gets 1. To the 2 to the G. So this would be 2 to the, well, 1 times 3 is 3. G to the 1 would be G times 1 to the 3rd, which would be G to the 3rd. And now we're going to mix it up a little bit. We have 7 to the 3rd in parentheses, 7 to the 4th times 7 to the 2nd. We have more parentheses. Okay, all these parentheses, order of operations. I need to do this inside parentheses first. So I'm going to multiply 7 to the 4th times 7 to the 2nd. Well, 7 to the 4th times product rule. We're going to add those exponents. So when I rewrite this, I'm going to have 7 to the 3rd in parentheses, 7 to the 6th. Now think. What's happening here? This is parentheses, but that's 7 to the 3rd. There's not an exponent attached to the parentheses. This is just saying I need to multiply 7 to the 3rd times 7 to the 6th. Same base, so I keep the 7. 3 and 6, when I have the product rule, I add them, and 3 plus 6 is 9. All right, new parentheses inside 9 tenths, I should say, P, 9 tenths P, and I have this 2. Now the 2 has to go see everybody on the inside. And you're like, but there's no exponents. Every number has an exponent. When we don't see it, it's a 1. Every variable has an exponent. When we don't see it, it's a 1. So I could rewrite this as, now think, everybody's going to be multiplied, every exponent. So I'm going to start with the 9. It's no longer 9 to the 1st, it's now 9 to the 2nd. Over. It's no longer 10 to the 1st, it's now 10 to the 2nd. And then I have this P. It's no longer just P to the 1st, it's P to the 2nd. If that exponent is attached to those parentheses, that exponent goes and multiplies by every single exponent inside those parentheses. We've got one more challenge problem. I've got 10 to the 5th times 10 to the 3rd, subtract. I have 10 to the 2nd inside parentheses raised to the power of 4. I'm going to follow my order of operations. I'm going to follow my PEMDAS. All right, I start inside parentheses, 10 to the 2nd. Okay, there's nothing else in there. I'm done with that. Exponents. Oh, well, I have lots of exponents, but is there anything that I need to use as an operation here? Exponents 10 to the second to the fourth, that's raised up. That's an exponent. So I'm going to go ahead and perform this operation. So I have 10 to the fifth times 10 to the third minus 10 to the second raised up would now be 10 to the eighth. Okay? Now I have all like bases, so I'm going to continue following my order of operations. I need to multiply. Well, I have multiplication. Okay. 10 to the fifth times 10 to the third. Then we multiply, keep the base, add the exponent, so that would be 10 to the eighth. I still have this other 10 to the eighth here, so minus 10 to the eighth. So I've multiplied. There's no division. There's no addition. There's just subtraction. So 10 to the eighth minus 10 to the eighth. 10 to the eighth minus 10 to the eighth. If I said 1 minus 1, what would the answer be? Yeah, 0. If I said 5 minus 5, what would your answer be? 0. Well, guess what? 10 to the eighth minus 10 to the eighth? 0. Anything subtract itself is always going to be 0. So as you are working with your product rule, you can kind of think of it like distribution. Look for the parentheses. If that exponent is attached to the parentheses, that means that exponent multiplies in, distributes in to every single exponent, even the ones you might not see inside those parentheses.